And our next speaker is Gillian Crowther, who's presenting on behalf of Lucille Leader, who many of you will know, but she's not able to attend today. She's watching on the webinar avidly. She's with us. And Gillian has helped prepare the lecture, so it's not entirely Lucille's lecture.
Forward, and how do I click forward from that? So good afternoon. Thank you very, very much. First of all, Rachel and Mark and Biolab, thank you very, very much for inviting us to speak. Yes, as Mark has just said, I am presenting this lecture on behalf of my co-author, Lucille Leader, and myself. She's the nutrition director of the Parkinson's disease Integrated Nutrition Clinic, where I'm a nutrition consultant, and Dr. Jeffrey Leader is our clinic medical director. So the title is Mitochondrial Support in Parkinson's Disease Management. And just to mention, yes, of course. Just to mention that the talk is dedicated to 3 colleagues who've contributed a lot over the past, although they've unfortunately passed away: Dr. Adeni Jones, Dr. David Freed, and Dr. Erich Siegel. And also just to mention that the presentation shouldn't take the place of the patient's medical team. We can't take we don't have any conflicts of interest regarding any of the nutritional supplements that we mention, neither of us. The structure will be, first of all, giving a very brief description of Parkinson's disease, and then talking about the etiology, again, just an overview in the short time we have, related to the mitochondria. Then we'll look at the factors compromising mitochondrial function in dopamine metabolism, and then look at the clinical approach, focusing on mitochondrial support, though it needs to be, as Jenny said about her patients as well, it does need to be general, because one never just uses one approach. So first of all, Parkinson's disease itself is a complex, multifactorial neurodegenerative disease that can be sporadic as well as gene associated. And many peer-reviewed research publications have shown how very connected it is to mitochondrial dysfunction. The aberrations include mitochondrial dysregulation, as well as genetic implications, and proteins are very often misfolded in the nervous system. The adrenal metabolism of patients is dysregulated, and there are issues with oxidative stress, enzymes, thyroid function, detoxification, the methylation cycle, and the microglia are activated. So all in all, this, of course, causes inflammation. The physical symptoms that are the most cardinal are based on dopamine deficiency, because it is due to a gradual reduction of dopamine in the substantia nigra of the brain. They are tremor and slow movement, stiffness, festination, which is these sort of tiny steps that you'll often see in Parkinson's patients, rigidity, and freezing. The metabolism of protein from dopamine to adrenaline is particularly key in Parkinson's, and the enzymes required for that are unfortunately often malfunctioning. Dietary protein needs to transition through phenylalanine and tyrosine to L-DOPA, and then to dopamine and adrenaline, cortisol and DHEA. But there is also one of those pathways, by the way, requires, well, they all require their own enzymes, but tyrosine hydroxylase is particularly important, and is unfortunately unable to function normally. And the other pathway that's also very important is that dopamine goes through dopal and ideally then is transformed into dopac and then HVA, which is one of the markers that we'll find on an organic acids test. But dopal is very toxic and it accumulates in Parkinson's disease and is not broken down to dopac very easily. And this disrupts mitochondrial function and causes the death of neurons in the substantia nigra. So it becomes, unfortunately, a bit of a vicious cycle. The misfolded proteins and the mitochondrial dysregulation are characterized by alpha-synuclein, which has already been mentioned in the Lewy bodies, beta amyloid and tau. And evidence suggests that S-nitrosylation, which is involved in the misfolded proteins, also impairs mitochondrial function. And so to look at the etiology for a moment, it's fascinating to think that in the dopaminergic neurons in the substantia nigra and specifically in the pars compacta, where dopamine is generated, but also, unfortunately, impaired in Parkinson's disease, you can have up to 2 million mitochondria in each neuron. This is a fairly recent discovery. The article referenced at the bottom does explain that, but of course, in Parkinson's disease, it will never be that much. They'll be, unfortunately, degenerating. But it shows how very hungry for energy these nerve cells are and how dependent they are on the mitochondria. So the various different aspects of mitochondrial dysfunction that have been recognized in Parkinson's disease are that oxidative stress, of course, has a huge effect on decreasing these millions of mitochondria in that portion of the brain. Pink, by the way, is a very, very important gene, PINK1, which is in fact mutated in Parkinson's disease, together with another protein product of a gene called Parkin. And both of these, the mutations, are involved in each of these pathways that ultimately can cause mitochondrial dysfunction. So the second is that the electron transport chain is affected, particularly complex 1, and that mitobiogenesis, that's the generation of new mitochondria, as well as mitophagy, are both impaired. And the movement within the cell that Rachel has described so beautifully, the axonal movement from the nucleus towards the membrane of the cell and throughout, that is impaired. And the ability to create both fusion and fission also is that they become unable to do that. And finally, also calcium homeostasis is also disrupted. So complex 1 in particular of the electron transport chain is a primary source of these reactive oxygen species. And this has been found particularly in the substantia nigra of Parkinson's patients. The factors that compromise mitochondrial function in dopamine metabolism are important. With the striatal dopamine deficiency, it is vital, of course, it's a mainstay of Parkinson's disease to have the therapeutic support of levodopa, that's the pharmaceutical, the precursor. But there are other pharmaceuticals required as well that are often used, decarboxylase inhibitors, COMT inhibitors, agonists, adamantanes, and anticholinergics. They all have their role, though with COMT inhibitors particularly, which inhibit the action of the COMT enzyme in order to allow L-DOPA to be utilized for longer. It would seem to be more useful, and this is something we do in the clinic, to do a check of the COMT genes of the patient to ensure that you don't have a huge dysfunction anyway, because you can adjust the dosage accordingly, and this often isn't done. So the L-DOPA administration does decrease the activity of complex 1, and although it's the most effective drug dynamically to alleviate motor impairment in Parkinson's disease, there's a lot that you can do to balance the effects of it so that they're as effective as possible without overdosing. It's the most effective minimum dose that counts. And this requires precise timing of proteins in relation to when the dopamine is taking, and precise timing of foods overall that is conducted very precisely at the clinic. And this is to avoid the off periods, off meaning when the dopamine has become very low for whatever reason, whether the patient is actually on an L-DOPA that's pharmaceutical or not, and to optimize their function. So I've mentioned the COMT inhibitors already. They're called L-Capone and Enter-Capone, the ones that are primarily used. And these do damage mitochondrial complexes, or at least the studies have shown that they can do. They, in fact, can uncouple oxidative phosphorylation and inhibit the mitochondrial enzyme complexes. So as mentioned, we tend to use life code GX, for example, to check the genes and then to adjust the dosage accordingly. So the clinical approach is always a multidisciplinary approach using collaboration with the GP and the neurological paramedical team of the patient for best and safe practice. And we use tests, often, well, always really, biolabs are included, as well as tests of intestinal status and routine medical tests where the GP will do them, of course, and regular measurement of the patient's oxygen saturation. The nutritional support is always based on biochemical individuality, so it's tailored according to the patient's results. And bowel function is monitored daily. Ideally, we like to get a kind of daily report back from the patient, because that's so important. And the diet and nutrient support are monitored closely as well. We also consider all of these specialisms depending on which are needed, and the patient's state: speech therapy, osteopathy, physiotherapy, remedial movement, O2 reports from their home oximeter, gastroenterology, ENT, occupational therapy, and other specialisms as needed. Psychotherapy and autogenic training are particularly essential because of the way that stressors affect the patients so greatly. If you can remove stressors, whether psychological or physiological, then you'll automatically see an improvement in mitochondrial function and the feedback loops that are affected that we looked at briefly earlier, as well as the response to L-DOPA. So the patients are advised to exercise appropriately, but to pace as needed as well, and not to overdo their exercise. Interval training has been found in studies to be useful, so that will often require an exercise therapist. The tests that we like to do are those that BioLab offers for the nutritional status of the patients, a nice broad nutritional screen. AONM's tests with Armin Labs for virus stealth infections, there's a specific panel for that, though of course that's always tailored to the patient's history and symptoms. LifeCode GX for the genetic aspects, Genova Diagnostics for stool tests, and TDL, that's the doctor's laboratory and the London clinic for general medical tests. The mitochondrial nutrients we use for the citric acid cycle are shown here in an overview. The mitochondria, as you know, are sort of within that circle. It's not just those that are required for the citric acid cycle or the Krebs cycle, but also for the electron transport chain. And even though I've sort of mentioned them there, we have according to each complex, that is a huge story in itself that Rachel has given us so much detail on already, as well as so many of the other speakers. The glycemic regulation is important for patients who have Parkinson's disease. The foods and the timing of the foods need to be based on what they're taking, the actual therapy that they're on, and their own biochemical needs. We do use MCTs, coconut oil, for example, foods based on coconut. But we have to be a little bit careful of the ketogenic diet. Not all the recommendations fit with the patient's needs because of the very, very careful adjustment of the timing to their medications. The dietary pointers that we use are to, will be very familiar to you, I'm sure, removing these items, but also being careful to replace them with appropriate substitutes. Gluten, lectins, and dairy. I'm sure I don't really need to explain why. It would take quite a long time to with each one of them, but I'm sure that most of you are aware of the inflammatory effects that they can have with dairy and the casein. I think you gave us some good explanations, and Jenny as well, as to why you have to be very careful of the growth factors. Oh, Sarah, of course, mentioned that as well. And then the inflammatory cytokines in red meat. But all of this is done very carefully and gradually. With a Parkinson's patient, you can't just sort of remove all of these at once. Artificial sweeteners, MSG, and of course, alcohol. There is an interesting L-DOPA replacement that you can use that's completely natural, called Mucuna pruriens. It's called the magic bean. In India, it's been used for millennia, really, and it has been found to be effective in the control of symptoms of Parkinson's patients. This isn't always the case. One has to trial it very, very carefully to find out if it suits the patient, but its benefits are interestingly closely linked to its interaction with the mitochondria. These studies that have been done, and this was done by Professor Lees, interestingly from a London university, and others have been performed as well, show faster onset and longer on time than L-DOPA in some cases. And it increases the activity of complex 1 in the mitochondria and has neuroprotective effects. The other components in Mucuna pruriens are CoQ10 and NADH, among others. So this is no doubt why it's or can be so supportive to the mitochondria. And interestingly, it's also able to regulate PINK1, which I mentioned earlier. This is a gene that is often mutated and affects the mitochondria hugely. Actually prevents their apoptosis. So you have these dysfunctional mitochondria that the body is unable to get rid of. And the other interesting aspect of Mucuna pruriens is that the main components component apart from L-DOPA is ursolic acid. And this actually has the ability to increase mitochondrial mass and ATP generation capacity. So a very, very interesting addition to the sort of pharmacopoeia in Parkinson's disease. So the nutrients that we consider using are the following, and they'll all be familiar to you, I'm sure. B vitamins, including folate, NADH, and vitamin C, methylation factors, minerals, such as zinc and magnesium, but we have to be very cautious of manganese, iron, and calcium because they have certain contraindications in Parkinson's disease that are backed up by literature. Amino acids, especially carnitine, L-carnitine, coenzyme Q10, glutathione, and alpha-lipoic acid for the reasons that have been described previously are particularly helpful. Resveratrol, because of its ability to activate PGC1 alpha and generate mitobiogenesis, the development of new mitochondria, as well as berberine, curcumin. And for the gut, S-Bouladi and butyrate. Of course, you've got to make sure that the patient is actually digesting, otherwise it's all for the birds. So that's a common problem, and digestive enzymes are very important, as well as probiotics and fatty acids. And the precursor to glutathione, N-acetylcysteine, has its place, but it can also act as an excitotoxin in patients with PD, so you have to be careful not to use too much of that. The this is just an overview of a few of the nutraceuticals that I've just mentioned, or nutritional items, which are that B vitamins have a particularly important function on the mitochondria in Parkinson's disease. The articles referenced here do back that up. And that's B1, B2, B3, niacin. Loved everything that we heard from the professor in Finland about niacin and B3 in general, all the different forms. Here, nicotinamide riboside is mentioned particularly for its ability to preserve nerve cells by boosting their mitochondria and resulting in new mitochondria and increased energy production. Folate and B12 are, of course, very important as well, though we'll always give complexes rather than individual vitamins in high doses in the clinic. Vitamin C counters the pathogenesis of oxidative stress and is of great benefit, maintains mitochondrial integrity in Parkinson's disease. This was an article specifically about dietary antioxidants in Parkinson's disease. And CoQ10 as well, of course, for its ability to transfer those electrons along the ETC, and it attenuates neurotoxicity. Glutathione prevents the degeneration of dopaminergic neurons, so that's a vital component, as well as maintaining the function of complex 1. Previously, that was considered to be the main involvement of the mitochondria in Parkinson's disease, but as shown earlier, it's now been found to be a much broader picture. So resveratrol, for its ability to generate new mitochondria, as mentioned, these are a number of articles that evidence that, as well as curcumin to preserve complex 1 activity in Parkinson's disease and regulate energy homeostasis. So there's a lot one can do, and much of it is specifically mitochondrial. The microbial metabolites will benefit greatly from S-Bouladi, we've found, and butyrate. These are very, very interesting articles here. And actually, there's one which also shows that S-Bouladi restores glutathione levels, which inhibit reactive oxygen species production. And that again was, I think, specifically in Parkinson's disease. So finally, when the oral route fails, if it does, and hopefully it won't in the patient, but if they can't take nutrients orally, then in the clinic, we consider whether the medical lead, who we always refer them to, feels that either pre-digested elemental tube feeding is appropriate or IV feeding. And if IV administration is used, then mitochondrial nutrients are always considered and supported incrementally as well. Just to mention that Lucille Leader and Dr. Jeffrey Leader have written and edited many books on Parkinson's disease, the most recent being the first one listed here, Parkinson's Disease, Reducing Symptoms with Nutrition and Drugs. And I'd like to just acknowledge Dr. Jeffrey Leader, who's the medical director at the clinic, and Professor Leslie Findlay, who's a consultant neurologist who's worked with us for many years. So I don't know how well I am within the time that...
Your timing was perfect. Thank you very much, Gillian.
Oh, thank you.
Yeah, questions? Dr. Wendy Denning, do we have a microphone?
Oh, I'm sorry. I was going to say to you, I don't have the answer to that because I didn't look specifically into statins, but I must say, I mean, Melody, who works with us as well, we don't know that statins have been recommended in the clinic specifically, though we wouldn't take the patient off them without, you know, consultation with the medical doctors involved if they were on them, but I haven't heard of them being used as an actual support.
Most of them are already on them. It's a question of, you know, whether you advise them, if they've got a strong family history of Parkinson's, to come off statins, or whether you say, actually, there's been some benefit, maybe stay on them. I think that's the kind of interplay, isn't it?
Yeah, exactly.
Yeah. But my question, you mentioned constipation, or you mentioned monitoring bowel functioning. And there is this, of course, this, you know, it appears that, you know, long-term constipation can lead to Parkinson's. And it's thought to be that interplay. You didn't mention anything about why you were concerned about daily bowel movements. And I just wondered why you were so kind of focusing in on that. So just be interested.
Well, because you'll get this log jam throughout the patient's system if they don't have good excretion.
Okay,
and,
so that was why, yeah.
I mean, the detoxification, such as you're enabling it at all, yep, in a Parkinson's patient, depending on, you know, how progressed their illness is when you get to see them, will obviously be severely impaired if they're not passing stool.
Thank you.
So it is considered very important.
Yeah. I get that.
Dr. Goodman.
You mentioned oxygen therapy. Can you, or you mentioned, you know, lowered arterial oxygen. Can you say more about that and why it happens and what the therapy is, whether you use HBOT, for example?
Well, we do ask for patients to get an oximeter and to use it at home and to repeat back their SATs.
But why? I mean, does the oxygen level go down in PD? And if so, why?
Well, I mean, obviously it's a mitochondrial condition to some extent, in that the mitochondria will be impaired. And you've got to, I mean, ideally,
so,
anyway,
so it's not that they have lower oxygen, it's that because the mitochondria aren't functioning, they need extra. Is that what you're saying?
I mean, I'd suggest that we ask Dr. Leader and Lucille Leader for a sort of specific medical explanation of that. It would probably be best. But I mean, I would assume that it can be a number of different things. It can be related to the breathing. It can be related to the function of the mitochondria, the inability to metabolize oxygen well enough. But
Okay,
it can also
you.
be due to physical stressors as well. Yeah.
Okay, any more questions? We'll just take one final question from this gentleman. Yeah.
I just wondered if you could quickly go through the water question.
Oh,
The water issue.
Yes.
I'd love to speak about it, but that's not so specifically related to what I'm presenting here with Lucille Leader. But the fourth phase of water, Professor Jeffrey Pollack, he's written a book on it. And actually the metabolic water that we're creating in our cells due to the mitochondrial function is something that's hugely neglected, actually. And I think that Rachel explained that brilliantly with her camel metaphor. So I mean, one day we'll have a whole day on that, right, Rachel?
Okay, thank you, Gillian, that's great.
Thank you very much.
So I would just cumulatively like to thank all of the speakers today. I think it's been an amazing day. I'm sure we've all learned a huge amount, and obviously the speakers have all put a lot of work into their lectures. So one final round of applause for all of the speakers, please. And I'd just like to thank the Biolab staff who I think are listening in outside for all the work they've done to help put this together. We couldn't have done it without them. Of course, finally, I'd just like to thank all of you and everybody on the webinar who's out there watching us for attending today. And I hope you've all benefited hugely from it. But of course, more importantly, I hope that your patients benefit from what you've learned today. So thank you all.